the way. That's why we cover the log here. So you might have an exponential equation. You go 2 to the power of x equals 8. That's an exponential equation. How do you solve it? Well, for this, you don't need a calculator. You don't need a log button. 2 to what power is 8?
4.
How about 3? Right? 2 to the third. But now let's change that. 3.25 to the power of x equals 17. And I want to solve it. The only other way to do it is guessing. Go, well, let me see. Maybe the answer is 2. So let me try that. You take your calculator, you start guessing there. 3.25, can you see it? To the power of 2. Let me try the 2. Oh, that's too low. Let me try the 3. 3.25 to the power of 3. Oh, that's too high. 17 is between 10 and 34, right? It's closer to 10. I go 3.25 to the power of, it's more than 2, less than 3. How about 2.5? 19, still high. 3.25 to the power of 2.4. Well, how long are you going to go guessing there? Oh, not bad. I need to go a little bit higher than that, 16.9. I need to be 17. So I'll do what? 3.25 to the power of 2.41 maybe? 17, oh, maybe less than 41 between. So you start guessing. 3.25 to the power of 2.405, because 41 was high. Ooh. Instead of 4505, maybe 4049. So I start guessing. 2.4. I said 05 is high. How about 04? Oh, getting closer. 17.00. But if I want 6 decimal places, I'm in trouble. That'll be the whole night. I can do this in less than about 40 seconds. What do you do?
The log on both sides?
Yep, take the log or the natural log of both sides. It really doesn't matter because that number is not e or 10. And I couldn't tell you why I chose the natural log. I don't know. I just wrote the natural log. Less writing, I guess. 2 letters versus 3. That's the only reason I can give you. Now use rule number 6. What can you do with it?
Move the x.
Yep, move the x to the front.
Divide both sides.
Divide both sides by what?
The log, or the ln.
3.25, right? And it's not a guessing game now. Here we go. ln of 17, close that parentheses, divided by ln 3.25. And it's 2.40. 4037685153.
Close.
I was 2.404. I came close by guessing. So that's where actually the log comes in. When you have an exponential equation, you want to solve it. The only way to take care of it is by taking either the log or the natural log. Now that wasn't a bad equation. And what about if that equation got really ugly on me? Like what? 2 times 4 to the power of x minus 1 equals 17 to the power of x. If you think I'm going to guess with numbers, you're crazy. There's no way I'm going to guess. Again, I can either take the log or the natural log. Since I did the log in the previous example, maybe I'll do what? I did the natural log in the previous one. I'll take the log here. The log of what? 2 times 4 to the x minus 1 equals the log of 17 to the power of x. Now let me look at the left side. What do you notice right here? What do you have? Well, you can't multiply this by that. There's an exponent here, Sebastian. But I see 2 times, right? There's a rule about the log. When you have multiplication, that's rule number, I think, 4. I should be able to break it down to the log of 2 plus the log of x minus 1. I mean, 4 to the power of x minus 1. Equals the log of 17 to the power of x. Now, if I use rule number 6, I have an exponent. What can you do with the exponent? I can take it and move it to the front. So this problem becomes what? Log 2 plus x minus 1 times log of 4 equals x times what? Log 17. And now from this point on is all algebra, no more log, basically. Let's see. I can distribute that. That's log 4 times x, log 4 times a minus 1. So I have log 2 plus log 4 times x, that's x log 4, minus 1 log 4, or just log of 4. So I took the log of 4, I multiplied it by x, now I multiply it by the negative 1. Distribute that. Now, if you want to solve for x, that means you want to move all the x's to one side, all the numbers to the opposite side, just like any equation. So I'm going to take that x log 4 and move it to that side. And when you change side, what do you do with the sign? Change the sign. X log 17 minus what? X log 4. Can I factor an x out of this?
You can't just subtract it.
No, because you don't know the answer to these. And we have no rule about subtraction. That used to be division here, if you remember that. Jennifer, when you have subtraction, it used to be division, so you can't really subtract them. But if I divide 17 by 4, it's a stupid number. It's not like I can't simplify it. The same thing, if I divide this, that's a half. Because it'll be 2 divided by 4. I just leave them the way they are. So I'm going to divide both sides by what? So it's log of 2 minus log of 4 over log of 17 minus log of 4. So if they ask for an exact answer, that's your exact answer. I know you can simplify this because that's subtractions. You can make it 2 divided by 4, but what's that number? Is that a half? And you can make that what? 17 over 4, which is what, 17 over 4? 4.25, I think.
Yeah.
If you divide 17 by 4, 4.25. But if they're asking for exact, I'm sure they don't want to use these numbers. They want you to leave the answer like this. But if you want to find the answer now, you can divide them on your calculator. Here, go, I got it now. Clear the log of 0.5 divided by the log of what? 4.25. So x will have to be negative 0.479. It took a whole page, but there's no way I'm going to guess on that and try to plug them in and see what works, what doesn't. So that's where the log comes in, solving ugly exponential equations. Let me try maybe another one. Just go to the end of the problem and pick something. Let's try another one. This was a big one. I should have kept it a little longer, but that's the example they use in the book. So I'll make an easier one than that to start with. Let's say I have 5 to the power of x minus 1 equals 0.07. Again, you can choose log or natural log. What do you want to do? Natural log, okay. Natural log of 5 to the x minus 1 equals natural log of 0.07. Rule number 6, that's the exponent rule. It says take that exponent to the front. Times the natural log of 5 equals the natural log of 0.07. And you're going to distribute that one. Natural log of 5 times x. I like to put the x first so people don't get confused. They think that's the natural log of 5x minus the natural log of 5. If you want to solve for x, you move everything that doesn't have x in it to the other side. So the natural log of 5 has to go there. And that becomes what? Plus natural log of 5 plus the natural log of what? 0.07. Now notice that's addition. Addition used to be what? That's rule number 4. That used to be multiplications. Because you have addition. That used to be multiplication. Now to solve for x, what do we do? Divide by ln of 5. And again, that's your exact answer, but if you want to simplify it, get some numbers for it, ln of 0.35 divided by ln of 5. Negative 0.652. If we are lucky, I'll wait till you finish writing.
So where do you get the 0.35?
That's a plus. It used to be multiplication, rule number 4. 5 times 0.07.
All right. I thought you were putting in the
Nope.
ln.
No, when you have a log plus a log, it used to be multiplications. So it used to be ln of 0.35. That's why I like to write the rules next to each one. Which rule did I use here? So when you're looking at that, it says where that number came from, rule 4. How come this one moved to the front? That was rule 6, the exponent. As I said, if we're lucky when we do these problems, you'll see something like this. E to the negative x equals 17.54. And if you see that, again, say thank you to them, because they just made the problem much easier. Once you see E in the problem, what do you want to do? You want to take the natural log. That's a smart way of doing it. And what's the natural log of e to the negative x? Negative x, yes. Natural log of e to any power, I'll keep writing it here, is the power. Because the natural log and e will cancel each other out. So you have negative x equals the natural log of 17.54. I don't want negative x, I want x. Either divide or multiply by a minus 1. So what's x equal to? Negative the natural log of 17.54. Again, either multiply or divide by negative 1 to make it plus x. So negative the natural log of 17.54. I got negative 2.864. So if you're lucky, you have e to the x in the problem, or you have 10 to the power. Let's see, you have a problem like this. 10 to the power. If you have 10 to the power, what do? The log, not the natural log. And again, the reason we do the log, because we have a rule that says log 10 to any power is also equal to the power. So that means x minus 5 is equal log what? 23. If you want to solve it for x, what do? You add 5 to both sides. 5 plus. Notice I put the 5 in the front, because if you put it after the 23, people think 23 plus 5, and they go add the two numbers. The log 23 is one package. Can't add 5 to a 23. You gotta add 5 to the answer of that. That'll be 5 plus log 23. 6.36. So that's how we handle exponential equations. We're not done yet, because this topic is what? Exponential and what? Logarithmic equations. So let's look at, so that's exponential equation. So let's look at logarithmic equations now. How do we handle them? With math, or carefully. We've done some of these. You're probably going to realize, oh, we did this. Something like this. Let me start with this one. 3 log base 8 x equals negative 2. And they want us to solve it for x. Again, I'm going to think backward. I'm going to use rule number 6. Rule 6, now I'm thinking backwards. It says if you have a number in the front of the log, that number used to be what?
An exponent.
An exponent. That's good. Now let's look at rule number 3. It says if you have a log on one side only, it's not on this side, you can change it to exponential. X to the third will have to equal what? 8 to the power of what? Negative 2. What is 8 to the minus 2? Yep, that's 1 over 8 squared, which is 1 over 64. So how do you get x instead of a cube? What do? It's the cube root of 1 over 64. What is the cube root of 1? And what's the cube root of 64? So x is 1/4. So I massage these rules. I work backward with them. Try to shrink the problem and take me back. Anytime you have the log on one side only and a number on the other side, you want to be thinking rule number 3. And again, in case you forgot rule number 3, that's this one. How do you go from log to exponential? You can go back and forth. That's rule number 3. Let me try another one. Let's say I have log base 2 of x plus log base 2 of 7 equals log base 2 of 21. Really doesn't matter what the base here. This is different than the previous one. Why? Because I had logs on both sides. I see an addition. See the addition? That used to be rule what? Rule 4. So that used to be what? So x times 7, which is 7x. I'm almost done with this. One more line.
3.
Yep. This side is equal to this. You get the log on both sides, the same base. The only way these two will equal to each other if what? If 7x equals 21. That's the only way they'll equal to each other. So x will have to be what? 3.
So you just ignore the logs?
Yep.
Go with the numbers?
Basically what I did, because that's log base 2, I did the inverse of that. I did 2 to the power. If you do 2 to a power, just like 10 to the power, remember 10 to the power of x is the inverse of the log, they cancel each other out. So if you have, we said log 10 to a power is equal to the power. And I didn't tell you 10 to the power of log x, for example, these guys will cancel each other out, just like these two guys cancel each other out. That's also equal to x. So if you use that logic there, these two, they'll cancel each other out. You have 7x equals 21. And the reason they cancel, they're the inverse of each other. When we did inverse function, when I used to describe inverse function, I used to tell people, imagine you have this box. And if you put a circle into the box, when it comes out, this is the function. When it comes out of this box, it's going to be what? A square. Somehow this box changed the circle to a square. Guess what the inverse function does? If you take that square and put it through the inverse function, it should change it back to what? Circle. So these two cancel each other out. You end up where you started with. So that's why 10 to the x and the log are the inverse of each other. Look where they're written. Just like sine of x and the inverse on top of each other. So if you go log 10 to the power, that's the inverse, they cancel each other. 10 to the power of log x, they cancel each other out. So when you see a problem like this, log base 2, you make it 2 to the power on both sides. And once you do that, gone, gone.
It only works when the base is the same.
Has to be the same. Yeah, because if the bases are different, I'm stuck. Might as well just leave me alone. It's not going to work. Or if you use common sense again, and never mind the math, go, okay, this side's equal to this, it's the same log, the same base. They have to be equal to each other. Let's try another one. Log 12x squared, no base, minus log 3x equals 3. I should have had a bigger paper for this. Bigger. Maybe not. Maybe I can fit it there. What do you see there? Addition or subtractions? That used to be rule which one? 5? So that used to be what? 12x squared divided by 3x. Can I simplify 12x squared over 3x? To what? 4x. Notice here, I don't have the log on both sides, so I can't say 4x equals to 3.
You can make it exponential.
Yes, rule number 3, exponential.
What happened to the exponent when you divided 12x squared?
Divide by 3 is 4. When you divide, you subtract exponent.
Okay.
X squared minus x is 1x. So 4x has to equal to the base, but there is no base here. So it's base 10. Now I can solve it. That's 1,000, right? And to solve for x, you divide by 4, which is what? 250? A couple more examples. That's why last time we're going over the rules, because we were laying the foundation for this section. This is where we need them. Log 2x minus 1 plus log x plus 4 is equal to 1. There's one thing I forgot to do. Well, I shouldn't say I forgot. I've been lax about it, and I got to pay attention to it here. When you get your answer, make sure when you plug that number in, none of these guys are negative, because if they are negative, what's rule number 1? You can't take the log of a negative number. So we should check our answer. All the ones we did so far were off the hook, because that's a 3. Log of 3, that's a positive number. That's not a negative number. I'm okay. This one, I'm not sure about this. So we have to be careful with it. Again, notice there is no base. I have a plus between them. If there's a plus, which rule? Rule number, is that 4? So that used to be log 2x minus 1 times x plus 4. If you multiply these out, you will have what? The FOIL method, 2x squared has 8x here. 8x minus 1x is what? 7x. What's a negative 1 times 4? Negative 4. I use the FOIL method. So rule 3 now, change it to exponential. It says 2x squared plus 7x minus 4 has to equal what? 10 to the power of 1, which is 10. Now bring the 10 to this side, you have a quadratic equation now. Can I factor that?
Where'd you get minus 16?
Yeah.
When you bring the 10 to this side, oh, 14.
Yeah.
14, thank you. Getting late. I was just testing you. I'm glad you spotted it now. Otherwise I have to erase everything. So now let's look and see. Can I factor that? 7 and 2, it doesn't look like I can factor it. Ah, nice. So I can solve this using what? Quadratic formula, yeah? Minus b plus or minus
b squared plus 4ac over 2a.
yep.
I hated that.
Should get a tattoo of it. Minus 7 plus or minus the square root of what? 49 minus 4 times 2 times a negative 14. God bless you, that'll be a plus. 4 times 2 times 14, that's 8 times 14. 112. Divided by 2 times 2, which is what? 4. 112 plus 49, 161. Four, not 2. So now I can just use my calculator to find the answer for the square root of 161. It's not a nice number. It's not a whole number. So it's negative 7 plus or minus 12.68858. That's plenty. Divided by 4. So one solution is going to be what? One solution is going to be positive 1.4221. That's when I use negative 7 plus. The other one, negative 7 minus 12.68858 divided by 4, negative 4.922.
And that would be rejected.
Now, when you plug it in, notice that's a negative number, almost negative 5, right? What's negative 5 times 2? Minus 1? Can you take the log of a negative number?
No.
Can't use that answer. This is roughly 1.5. What's 2 times 1.5? Almost 3. 3 minus 1? Positive number, right? That's okay. Here, 1.4 plus 4, 5.4, positive number, I'm good. So you should always check your answer, make sure the answer you got there does not make this value negative, because it kills rule number 1. You can't take the log of a negative number. That says you can't use that answer. So that is actually the last section in the log. That's it. So now you're going to have